We have covered a variety of instruments throughout our education series, and we'll highlight some additional instruments that are needed throughout the industry. These instruments are likely to be covered in more detail in future episodes, so consider these very high-level overviews. Our journey begins with high-performance liquid chromatography, or HPLC. This instrument is the workhorse of pharmaceutical analysis. With its ability to separate, identify, and quantify compounds in a mixture, HPLC plays a crucial role in quality control and research. In HPLC, a sample is injected into a stream of solvent and pushed through a column packed with a stationary phase. The compounds in the mixture interact differently with the stationary phase, causing them to separate based on their chemical properties. A detector then analyzes these separated compounds and can provide insight into the stability or solubility of the component of interest. Next on our list is particle size distribution analyzer, or PSD. In formulations, understanding the distribution of particle sizes is crucial for optimizing drug performance. PSD analyzers offer two primary modes of measurement, wet and dry. Let's start with wet PSD analysis. In this method, the sample is dispersed in a liquid medium, typically water or a solvent, to prevent particle aggregation. The dispersed sample is then analyzed using techniques such as laser diffraction or dynamic light scattering. Conversely, dry PSD analysis involves measuring the particle size distribution of a solid sample without dispersing it in a liquid medium. This method is commonly used when dealing with powders or granules. By understanding the distribution of particle sizes, scientists can tailor formulations to ensure optimal drug performance, stability, and bioavailability. Now, let's explore Karl Fischer titration, often referred to as KF. Water content is a critical parameter in pharmaceuticals, affecting stability, shelf life, and thorough understanding of new crystal forms. KF titration is the gold standard for accurately determining water content in a sample. During KF titration, a sample is dissolved in a solvent and titrated with a Karl Fischer reagent containing iodine. Water in the sample reacts with the iodine, producing a change in conductivity that allows precise measurement of water content. Last but not least, we have gas chromatography, or GC. This versatile instrument is instrumental in analyzing volatile compounds in pharmaceuticals, such as impurities, residual solvents, and active ingredients. In GC, a sample is vaporized and injected into a column where it interacts with a stationary phase. As they elute, the individual vapors trigger signals in the detector, which can be matched against a standard curve for identification and quantification of these compounds, which can provide insight into the phase origin of a new crystal form and quantify residual solvent content to ensure it is below the threshold based on the ICH guidelines. Thank you all for joining today, and we look forward to seeing you in the next episode.